Okay, let's dive into this. Welcome to this explainer, where we're going to unpack one of the most baffling and honestly monumental geological mysteries on our entire planet. When most of us picture the Grand Canyon, we see this towering, incredibly complete record of Earth's history, right? Just perfectly preserved in stone. But geologists, they see something totally different. They look at it and see a scene where a massive, almost unfathomable piece of our planet's history is simply missing.
It really begs this incredible central question. How do over 1 billion years of Earth's rock record just vanish into thin air? Seriously, we have this beautifully complete geological record right in front of us, with layers stacked so neatly on top of one another, kind of like an open book. But as we read down those rocky pages, millions, and in some spots over 1 billion years of time have disappeared, without a single trace. No way, right? Today, we're going to treat this like a giant detective story, and try to figure out exactly where that time went.
Section 1. Earth's Incomplete Biography.
So, to understand how something this massive gets lost, we first have to understand how the Earth actually writes its autobiography. Think of the planet's rock layers as acting like a giant, ancient memoir. The indigenous Paiute beautifully described the Grand Canyon as a mountain lying down. And later on, the 19th century geologist John Wesley Powell gave us this absolutely perfect metaphor, calling the canyon a library of the gods. In this vast library, the rock layers, what geologists call strata, are the ultimate storytellers. They preserve the whole dramatic history of our planet, from shallow seas to violent tectonic shifts.
Now, what's really interesting about this 5 million figure is that it's a bit of a brain teaser that geologists absolutely love to share. The massive canyon itself, like the actual physical gap in the Earth, was carved by the Colorado River only about 5 to 6 million years ago.
But contrast that recent carving with this completely massive number, 1,750,000,000 years. That is the staggering age of the oldest rock sitting all the way down at the very bottom of the canyon. It's this wonderful bit of irony, really, that in the grand scheme of geology, a massive river carving a miles-deep canyon 5 million years ago is basically considered, well, recent history. The physical canyon is practically a newborn compared to the ancient stone it's actually made of.
Section 2. Reading Earth's Rocky Pages.
Okay, so how do geologists actually decode this massive ancient library of stone? Well, to solve our missing time mystery, we have to figure out how to speak the rock's language. If the giant layers of rock are the chapters in Earth's biography, then sediment is the alphabet. Sediment is basically just worn-down fragments of rock that get moved around and deposited somewhere else. You literally cannot read this planetary history without understanding how these tiny fragments form the ABCs of our story.
Let's move to and see how this builds through the field of sedimentology. It's an incredible chronological journey. First up, weathering wears down existing rocks into sediment. Second, erosion physically moves those little fragments around via water, wind, ice, or just gravity. Third, deposition drops them into lower elevation basins. Think of the massive Colorado River basin. And finally, burial compresses those piled up fragments down so deeply they literally fuse into solid sedimentary rock.
Over millions of years, those buried beds pile up to become strata. These are the literal chapters in Earth's tell-all memoir. And let me tell you, these chapters are packed with clues. Tiny ripples, mud cracks, and angled layers called crossbeds can literally tell us which way ancient winds were blowing or rivers were flowing. At the top of the canyon, we even find layers absolutely packed with marine fossils. Actually, scratch that. Think about that for a second. That tells us this entire dry desert landscape was once sitting peacefully at the bottom of a shallow sea. How cool is that?
Section 3. Rules of Relative Dating.
Of course, Earth didn't, nicely date stamp its chapters for us. So to figure out what's missing, geologists have to use a specific detective toolkit called stratigraphy. This is the study of the geological record through strata, and it helps us understand the relationships between different rock layers and deep past events. It's this brilliant method we use to figure out the exact sequence of events, even when we don't know the absolute exact numeric dates they occurred.
So, the crucial point is that these 4 principles of relative dating work together to solve our timeline. First, faunal succession uses fossils, like those creepy-crawly trilobites that only existed during brief, specific periods, to match rock layers across huge distances. Then, superposition is very straightforward. Bottom layers are laid down first, so they're obviously older than the top layers. Original horizontality means sediment naturally deposits in flat layers due to gravity. If they're wonky or tilted, it means tectonic forces totally messed with them later on. And finally, cross-cutting relations tells us that if a rock layer cuts through another, the interrupting rock is always younger than the rock it's interrupting.
Honestly, that last one, cross-cutting relations, is basically classic younger sibling energy. I mean, just picture a hot, young, igneous rock violently barging into an older, well-established metamorphic rock and completely interrupting what it was doing. The one doing the barging and interrupting simply has to be the younger of the two, right?
Section 4. Gaps in the record.
All right, now that we understand the rules of the timeline, we have to pivot to the scene of our geological crime. What happens when major pieces of information are completely missing? Well, geologists call these gaps an unconformity. This is a visible boundary between two sections of rock that represents a literal gap in the geological record. These are the missing pages or completely ripped out chapters where Earth actively edited its own record, either through intense erosion washing the evidence away or simply a massive lack of sediment deposition over time.
There are actually a few specific ways Earth edits its own story, categorized into 3 types of unconformities. Take a nonconformity, for example. This is when newer sediments are deposited directly onto eroded igneous or metamorphic rock, showing a really clear shift in environment. Then you have a disconformity. This happens when there's an invisible erosion gap sitting right between 2 perfectly horizontal sedimentary layers. It's sneaky for sure, but very revealing. And finally, there's an angular unconformity, which is when older tilted rocks are eroded completely flat before new horizontal layers are laid down right on top. By looking for these specific clues, geologists know exactly how to spot these historical cover-ups.
Section 5. The Great Unconformity Mystery.
Okay, armed with our geological toolkit and knowing how to spot a gap, let's bring it all back to the Grand Canyon and tackle that massive missing chunk of time I teased at the very beginning. The granddaddy of all missing chapters is known quite simply as the Great Unconformity. In the Grand Canyon, this is the literal scene of the theft. It's this stark boundary where relatively newer, layered Paleozoic rock meets the extremely ancient, deeply buried Vishnu basement rocks.
When geologists applied relative and absolute dating to that specific boundary, they discovered a staggering gap. I mean, at this rock line, the timeline just stops, and it doesn't pick up again for an incredibly long time. In some places along this boundary, up to 1.2 billion years of geological history are just gone. Poof. Literally erased from the Earth. Let that sink in for a minute.
And this brilliantly illustrates the sheer scale of the situation. Think about the entire 4.5 billion year history of our planet. The Great Unconformity represents a full 25% of Earth's total biography that was either erased or never recorded in the first place. And here's why this matters to us. This isn't just a localized anomaly. This massive gap exists globally. 1/4 of the entire planet's history. The very history that, set the stage for complex life on Earth is missing everywhere.
So, what exactly did Earth do on its billion-year gap year? Well, we have 3 leading, unconfirmed suspects in this geological cold case. Suspect number 1, powerful glaciers completely ground down the landscape during a snowball Earth period where the planet's surface was totally frozen over. Suspect number 2, a past supercontinent named Rodinia began to violently break apart. This would have caused massive land uplift that triggered severe erosion, basically wiping the record clean like a giant Etch-a-Sketch. And then there's suspect number 3. It wasn't just one massive event, but multiple, smaller periods of immense erosion and zero sediment deposition acting together over a billion years.
As of right now, the Great Unconformity remains one of geology's greatest unsolved mysteries. Our planet's rocky pages give us absolutely brilliant insights into ancient oceans, tectonic collisions, and early life, but man, they are also absolute masters of keeping secrets. Which leaves us with one final thrilling thought to ponder. If an entire quarter of Earth's history can just be scrubbed from the record, what other massive secrets is our planet keeping to itself? Keep looking down, keep asking questions, and I'll catch you in the next explainer.